All right, we're going to talk about finding roots when the indexes are odd and even. So just a short introduction now. Did you know that all radicals with an even index, for example, a square root, index is 2, and a fourth root, index is 4, have two possible answers. So if we're looking for the square root of 49, we're thinking what number multiplied by itself 2 times would give you 49? And most people would say, miss that 7, because 7 multiplied by 7 is 49. Absolutely. However, what if I told you there's another possible answer where I could multiply 2 identical factors and still get an answer of 49? We need to think back to our integer work. A positive 7 multiplied by a positive 7 will give me a positive 49. I know 7 multiplied by 7 is 49. However, I also know the rule that a negative multiplied by a negative will also give me a positive. So technically, if I ask you what's the square root of 49, you could say, well, Miss, 7 is the square root of 49, and negative 7 is the square root of 49, and both would be right. So we need to decide, when do I have to tell you 2 answers, or when do I have to tell you 1? When we see this symbol written on the page, the square root symbol is already there. It's understood to be the positive or the principal square root. So when we have that symbol there, we're only expecting one answer only. And that answer will always be the principal square root. So in this case, I would say positive 7. If I look at the fourth root of 16, once again, the fourth root here is an even index. If it's an even index, I'm thinking what number multiplied by itself now 4 times would give you 16? Well, 2. 2 multiplied by 2 multiplied by 2 multiplied by 2 is 16. But I can also look at all negatives. Negative multiplied by a negative is positive. This positive answer multiplied by a negative will make my next answer a negative number. This negative multiplied by the last negative 2 will make my overall answer a positive 16. So while the fourth root of 16 is both 2 and negative 2, we're looking at only the principal square root, so we're going to say the final answer is 2. Keep in mind that there are 2 possible answers, and there are some circumstances later on that we'll look at where we could consider both of them. So let's try this now. Evaluate example 4, the cubed root of negative 8. I'm looking for what number multiplied by itself 3 times is going to give me negative 8. Well, I know the cubed root of 8 is positive 2. 2 multiplied by 2 multiplied by 2 is positive 8. If I switch that to negative 2 multiplied by itself 3 times will give me that negative 8. Think 1 negative, 2 negatives, that's positive 4, multiplied by another negative 2 is going to give me that negative 8. I want you to try now on your calculator to find the square root of negative 16, and it's important that you write negative 16 underneath the square root sign. So on some calculators, you're going to have to hit 16, negative, and then square root. It seems weird, but that's how the calculator is set up. On some other calculators, you're going to hit square root, then a negative, and then put 16 in. Hit equals, and tell me what happens. Some calculators will have a little e up in the corner. Other calculators will have an error message. It's important that you know what your calculator is going to do there. And the reason your calculator is saying, no, sorry, I can't do that, is because your calculator cannot find 2 identical factors that multiply to give 16. We know it has to be 4s. 4 multiplied by 4 is 16. Positive multiplied by a positive is positive. A negative multiplied by a negative is positive. So negative 4 could be an answer, but it gives me positive 16. The only way to get a negative 16 underneath that root is if I multiply a positive with a negative. And if they're identical factors, that option is out. There is no way to find 2 identical factors that are going to multiply and give me that negative 16. So our note for ourselves here, we understand the calculator is going to tell us error. We cannot take the square root or any root that's an even index of a negative number. Why is the cube root of a negative number possible, but the square root is not possible? Well, let's think about it. The cube root of a negative number is possible, like the cube root of -8 we just did. And if I look at the cube root of -8, I had -2. -2 got multiplied 3 times. So if I'm looking for the cube root of a negative, I have 3 negative factors. An odd number of negatives multiplied will always give me a negative answer. So let's jot a little note there. An odd number of negatives multiplied will have a negative product. And that'll work for cube roots, fifth roots, and 7 roots because all of the indices are odd. However, if I'm trying to find the square root of a negative, the only way I can get 2 identical factors is if I have a positive multiplied by a positive. That gives me a positive answer. Or again, a negative multiplied by a negative is positive. I'll always have a positive radicand. And that'll work for any even index. So if my index is a 4th root or a 5th root, or sorry, a 4th root or a 6th root, or an 8th root, and so on. I can't have negatives underneath an even index. So let's look at example 5 as a your turn. The answers will be posted in your Google Classroom. I want you to try each of the 6 questions in example 5 and check your work online.